I'm going to talk about Node and Docker together because we're here at Require Lex and Docker Lisbon. It's going to be an introduction to Docker mostly, but just in the context of Node. Okay, so first I'm going to talk about what Docker is and some introduction, why you might want to use it. Sorry, you guys have heard this already because I forgot to record it. And then talk about why I think Node and Docker are particularly good together. And I will give some introduction, like some. I can get out the terminal and we'll do some Dockering, and then give an example of building a very simple Node app and deploying it with Docker on DigitalOcean. So hopefully that all goes according to plan. Okay, so what is Docker? First of all, I should say, who has sort of had experience with Docker, kind of like used it, or anyone? Cool. And like just vaguely familiar with it, sort of. Cool. So it's not brand new to everyone, but so I'll give a bit of an intro anyway. Where it says with good UK, that should be good UX. So Docker is like Linux containers with good user experience. Linux containers have been around for a while, but what Docker have done so well is made it really easy to use and made it so that developers really love it. So it's become really popular. Because before it was kind of difficult to use Linux containers to deploy stuff. You had to be it was really low level, and it was quite challenging. And it has something, not a package manager, but it's kind of analogous to a package manager. It's not only easy to do Linux containers, it's easy to distribute them and run them and share them and things like that. That's what makes Docker really cool. But underneath, it's just starting and stopping Linux containers. And what are they? So they're, if you're used to Unix in some way on OS X or Linux, it's kind of like a chroot where you can say to Linux, from this directory, make it look as though this was its own empty Linux system, and you kind of can't touch stuff outside of it. So Linux containers are kind of like that, but with a whole bunch of other things around them that make them sort of isolated and secure, and you can sort of control resources, like say this one can only have this much RAM and this much CPU and these kind of things. There's a bunch of sort of rules around something like a chroot, you can imagine it. And they're much faster to start than virtual machines. If you make a comparison to them, it's probably something we're all familiar with. To spin up a virtual machine can take minutes, as you probably know. And whereas a Linux container can take like a fraction of a second, depending on what it's doing. And they have direct access to the operating system resources, so they're much faster. With a virtual machine, it's obvious really, but you're going through layer upon layer right down before you get to the hardware, and even then it's like before that you've got like an emulation layer. So whereas with Docker or Linux containers, it's kind of like you're running a process directly on the OS, but with a lot of the benefits of VMs. So that's what makes them really cool. Like I said, Docker isn't new, but they sort of nailed the user experience for developers. So Docker itself, like what is it when you install it? You get a daemon that has an API. It's kind of like a process monitor of containers, and it has an API that can tell you what's running and start and stop things and that kind of thing. And you can use that remotely, and it is a command line interface. The thing when you say Docker root, Docker build, Docker run, that Docker thing, it's a Go binary. There's a client of that daemon. Talks to the daemon and does everything. So when you say things like Docker run, you might think that you're like forking off a process or something like this, but in fact you're talking to Docker running as a daemon and asking it to do things for you, which has interesting side effects, but I won't go into all that. And it has a few other components now, which will be part of core Docker soon, or the core Docker experience soon. But at the moment they're kind of separate, and that's Docker Compose, formerly known as Fig, and Docker Swarm, which is a sort of a way to bring together multiple Docker hosts, and Docker Machine, which I don't really know much about, to be honest. I think it's for like initializing machines so that they can run Docker when they previously couldn't, something like that. Okay, so why I think Node and Docker are a good pair. Docker best practice says that you should run one process per container. So your containers, you may have a bunch of them all across your host, but all of them are just a single process thing, which makes them really easy to manage and move about and scale, because it's not like, I mean, there will always be difference in sizes, but it's nice that it's nice when they're single processes and small. You can fit a bunch of them in a host. And if you want to run something in a container that has multiple things, let's say a web service, a MongoDB, and all this, you can put all this in one container if you want. But it's actually nicer and gives you more freedom to be able to break them up in separate containers, be able to put them on different hosts and things like that. So given that Docker best practice is one process per container, Node.js, as we know, is single process executable. So it works really well to run inside a container. Whereas if you compare to something like Java, where you might have, let's say you got like an HTTP service in Java, depending how it's built, it might have like multiple threads, which are basically processes. And you're running all that inside a container. It's no longer a single process container type of thing, whereas Node is particularly suited to it. So I think they work really well together. Okay, like I said, you probably can't really that can. Okay, let's see how it goes. Okay, so there's a bunch of terminology in Docker which can be really confusing. Talk about like images and containers and repositories and registries. All of them sound like the same thing when you first start using it, and it's quite confusing. And to be honest, one explanation probably won't change that, but for me, I found it difficult when I began. So images and containers are the thing you probably work with the most directly anyway. An image is, you can imagine as a tar file. It is sort of ultimately a tar file, but it's a little more than that. It's a tar file with both metadata and all the things inside it that need to be in your container, such as your application. It's basically the unit of distribution in Docker. It's a thing that you will download when you pull something. It's a thing that you'll put on a server and you end up running somewhere else. It's a thing that you move around. Often the analogy in Docker is of like shipping containers moving around. Actually, it's not the containers at all that are moving, it's the images. Whereas a container is basically an instance, a running instance of an image. So you might think of it as like applications versus processes. Applications are the image, and processes are the containers. Just to oversimplify, but a container is basically you unzip the image at the top, and using the metadata that's in there to run it with as a Linux container, it's your root type thing with all the properties that go with it. So hopefully that makes sense. And then layers is an image is made up of layers. If you think of it as this is one of the coolest things about Docker, but it's also kind of hard to grok initially. But if you imagine you have a container that is basically like a basic Linux OS with I don't know, something installed, let's say Redis, let's say. Then you can take that and you can make another image based off it. You can specify that as like the base one, then you say, and I'm also going to install Node. Right, this is violating the single process, it's just an example. So you can build them on top of each other, and these things are all called layers. Even the most basic one of them, even though you've not specifically broken it up into small things, Docker will be splitting them up. What that allows Docker to do is, let's say you have like 10 images that you've pulled and you've got stored on your machine. Docker will know that, say, the first 5 of them are all the same shared layer. You only have to download them once. It will save space and will make it faster to start things up. So Docker is able to speed up both the download and the start of things by using layers, by splitting images up into layers. So that's why when you do like a Docker pull, you'll see it pulling all these layers, and you get all these different progress bars going at different speeds. They are all the individual layers. But ultimately we talk about one image, which is, say, Redis. Redis is an image you might download. Layers are inside that. Okay, and then repositories and registries. Another one I found particularly confusing when I began. A repository is analogous to a Git repository, whereas we store code and files and images and whatnot in a Git repository. In a Docker repository, we store one image. So if we take the example of Redis, let's say you're using the image Redis, then Redis is the only thing that lives in that repository. The Docker image for Redis and all of its layers and associated metadata. And a history of all the tags. An image can have tags, which is much like they are in Git, which is just versions basically. Okay, whereas a registry, so if Git repositories are analogous, if Docker repositories are analogous to Git repositories, then a registry is like GitHub. There are many other servers that run that act as Git repositories other than GitHub, but GitHub is like a popular one. So a registry is a place that hosts Docker repositories, and there can be many of them. There is a default one that, if you don't specify, you're using the Docker Hub. That's a registry, and you might have an account there and a username and store a bunch of images in repositories. But you don't have to use the Docker Hub. You can use other ones. There's one called key.io. So does that kind of make sense? We store images in repositories. A repository lives in a registry, and when you run an image, you get a container. Cool. So yes, a registry houses multiple repositories. A repository stores one image and its namespace by username. For example, CoreOS/etcd, it's username/name. Or I might have one called myAPI, so my users/myAPI. When you take an image from a repository, it's called pulling it. You pull an image from a repository, and you run containers-based on images, as I said. So there's a one-to-many relationship between images and containers. You can run as many containers as you want based off a given image. Okay, so very quick intro there to talk about. Okay, so the Docker Hub is Docker's own hosted registry. There are others, as I said. To give you an example of that, I'm going to just quickly show you. Hopefully I haven't got anything loaded up here. So if I go into the repository, go into the Docker Hub and browse the registry, you'll see that there are a bunch of things in there like Ubuntu, Node, Mongo, Debian, Redis. All these things are repositories that store an image. So take Redis for example. We see that it has a number of tags. You can say Redis:latest and you'll get 3, probably 301. You can say Redis:3, you'll also get 301. You can also go 2.6.17 if you want. And you can see other tags in there. If you have an account on here, you can have a bunch of repositories yourself. And just to show you what that would look like. So you can see here that I have 6 repositories that are all public, I think. You can also have private ones. If you have a paid account, you can have private ones. I do without using it, but I should cancel that. So you get the idea. And I go back to my... Cool. By zooming it in before, I kind of messed up the... That looks better, I think. Okay, so I'm going to go through a few examples on the command line so you can get a feel for it. Okay, so let's start with Docker info. Let's make this quite big because we can. Docker info gives you some basic information about your Docker installation. It'll tell you which storage driver you're using, which is an interesting subject to time for, I guess. But how many basic system information. Which kind of, here we're using boot to Docker because I'm on OS X obviously, and that kind of thing. Okay, so let's pull an image from the Docker Hub. Let's take Nginx. Don't think I did this before, so it might take a few minutes. I won't wait for that.
Will it take advantage of previous layers you have?
It will, yeah. So let's say Nginx is based off Ubuntu. I think it might be. Maybe it's based off Debian. Then if I also had installed, say, the Node image, which was also based off that, it would know not to pull that Ubuntu one. It would only pull the subsequent layers.
Great.
So it may not take too long after all, because I think I have.
So I guess that also makes for a good practice when publishing containers. Make them based on as most of a high-level image as you can.
Yeah. Add as little as possible to it so that it can reuse other things. Definitely, and generally, it was quite fast, so it must have been the case. And generally try to optimize.
Are those all layers?
They're all layers, yeah.
Okay. Could you see what they are?
You
Like,
can.
are those like hashes that identify them?
Yes. I will do this only very briefly, but if I, because it's a little more complex because we're on OS X. There is a directory in every Docker installation. I'm trying to remember where it is.
Do you want to check?
No, no, okay. I'll stand up again in a second. Thank you. Maybe containers. AUFS, of course. Yeah, layers. Something like the thing that I copy and pasted, and you'll see that has stuff in it. Maybe. Okay, because that's like a.
Yeah, it's
So it's not an ID for the hub,
It's not an ID for the hub.
for the Docker hub, for something that's online.
It is
Could be
because
used only internally for Docker.
the ID is the same as it is on Docker Hub, like it's like universal ID.
Okay.
But I can't remember how to do it right now.
Oh,
but
sorry.
ultimately, like in here is what I was saying is like a tar file with metadata. If I could find it, there are tar files, and you can look inside, and there's like a JSON document, and there's other files,
great.
and they're all. You can find every individual one
Cool.
and look out one line and see which one it was.
Cool.
That's right. Cool. So there we did Docker pull Nginx, and I can also pull a specific version of it. 1.7.1, for example, which was an older one. So this will pull something, but probably will share some of the other things that are already there. That shouldn't take too long, but never mind. And then we can see which images we have pulled before. Oh, we'll wait for this, it should take a second. Do stop and ask questions at any point if I'm going too fast and not making sense.
Is there, if I install a command line application, there are probably some command line flags I can use to configure it. If I install a daemon, there's probably something under /etc that I could edit and configure. Is there a common practice or convention to configure images or containers?
Do you mean you don't mean the Docker daemon itself, you mean things that you're running inside?
Let's say I want to read this, but I want it on a different port and with some custom configuration. Would I need to generate an image of my own based on the common Redis?
Okay, so what you would do then is you would go to the Docker Hub and look up Redis. And in fact, let's do that. And you would find that it has like a README, much like every GitHub repo does, and it would tell you the kind of things you need to know for that. So this is Redis here. It will say here, if you need to mount a volume, you do it this way. If you want to use different ports, you do it like so.
So there's a way of passing configuration through Docker?
Yeah, it's basically you send environment variables and command line arguments.
Oh, great.
It allows you to do that. And if that still weren't enough, and it probably will also provide a volume mount if you wanted to change the config file. You could make a directory on your host, put the config file there, and say to Redis, your etc whatever directory.
Between the
Yeah,
container and your.
It comes down to a discussion probably about a Docker file, which we will come to in a minute. Maybe we'll revisit some of that then. Okay, so we can view the images that we've downloaded. I will just grab that for Nginx so you can see, because I got a bunch of things. You can see here that there's Nginx latest, and then there's 171, which we downloaded specifically just now. And just to scroll up to the headings. So these fields are repository name, then tag, and then image ID, which is that global ID that we were using to look up I was trying to find this file before.
Yeah.
When it was created, how big it is, basically. Okay, and then we can remove downloaded images. Let's say we don't want Nginx. Docker RMI Nginx, or we don't want 171, for example. You can remove it like this. Brilliant. And then now we can see we have the other version still, but not 171. What that'll do in practice is only delete the bits that are specific to 171. So it hasn't deleted, like, if it's based on Ubuntu, it's not going to delete that source. Okay, so let's run some containers. I've got a typo here, but never mind. So we can say we're going to run nginx, which is the last argument. That's the name of the image that we're going to run. We're going to say -d, run it as in the background. And we're going to say here map the nginx port 80 to port 8080 on the host. And we're going to give it a name, nginx, which is just handy.
So the last name is of the image and the first name is for the container?
Well, first name is for like a convenient name that we want to give it so that we can refer to it when we want to start and stop it to the container. Yeah, so we could call that like require X demo version of nginx, and we can then use it like that. Call it whatever you like. So now we can see in Docker PS that we have one container running. It is it comes from nginx. The nginx is the image we used. It's been up for a few seconds. There's port 443 and port, which we're not mapping anywhere, but port 80 is being mapped to port 8080. We should be able to see on here that port 8080 is there. No, it's not. Why not? Oh, of course, I just switched from Linux to OS X. So if we were to go into, I was planning to do this talk on Linux. So if we go in here, into the boots Docker, we'll see that there is 8080. And if we do a curl on that, we get the standard nginx thing page. Okay, if we go back to my host, I can also do, what's
to Docker shell needs? I just go to Docker IP.
Yeah, what is that IP? Do I even have it exported? I'm not sure.
That's a command that gives you the Docker.
And put in Docker Rust.
Cool. Yeah, okay, so I can also access it from my host as well, because boots Docker, if you're not familiar, is because OS X is not Linux. You might be thinking, how can you run Linux containers? You do it by running boots Docker, which is a Linux VM. So you have to use the IP address of that whenever you want to talk to Docker, which is a bit annoying. Okay, so there we are. Show view running Docker containers with Docker PS, and we can stop one. We can stop the one we just made. We just work with the container ID, or we can also work with nginx because we gave it a name. That's the reason to give it a name. It's handy. Now Docker PS, there's nothing. Okay, we can also do Docker PS -a, which is show running containers even if they're show containers even if they're not running anymore. They've been recently stopped, because stopping it doesn't remove it. Now we can remove a running container, a stopped container, with Docker RM, and we can see it doesn't even appear on PS -a. Okay, and when you're doing Docker run, you can do a whole bunch of other things like mount volumes, as I was saying earlier. You can specify environment variables. Say if we were, where was I? Yeah. So when I did Docker run earlier, I could also say like -e envar1 equals blah. You can send environment variables, and you can mount volumes and do all kinds of things, which I won't go into right now. Okay, so now the Docker file, which will touch on some of the stuff you're asking there before you. So the Docker file is basically a text file that describes how to build a Docker image. So when we were saying before that you may have something based off Ubuntu, and then you put nginx in there, that's basically, I think I was talking about nginx, I was talking about Redis, never mind. So these containers that we've been working with, say nginx, will have a base OS, and then they'll add some things, and then they'll build it, and they'll put it on the hub so that we can download it. the way that they'll do that is by writing a Docker file. Here's an example of something which is like a basic, this is a basic example for a Node app. So this person's, I ripped it off the internet. So they based it off CentOS, and then they've downloaded npm. They've installed npm, and then they've added their Node app, and then they run npm install, expose a port, and then say when you run this, you need to run this command. And then so what that will do is build a Docker file afterwards. I'll give you an example. It'll build a Docker file that has run all those steps in a Linux machine, and then like tarred it up and put it on the Docker Hub so that you can download it. That's basically what a Docker file is. So we'll do an example of this. Here is the one that I have on the slides, or maybe one that I changed. Yes, it's quite different actually. No, sorry, I'm one slide ahead of myself. Okay, so just to explain what these lines do. The from line is the image that you're going to base the Docker file, the Docker image off. In this case, I'm specifying CentOS. And what that will end up being is the first layer. And every line that we put in a Docker file afterwards will make another layer. And then run just runs a shell command of some kind. Add takes a file from the host and puts it into the tar file that becomes the image. We run another command. We expose a port which just says to Docker, we're going to use these ports inside the container so that you know to map these if the user wants them onto the host in some way. And then as I said, the command that will actually get run when you run the image, when you run the container based on this image, which is basically Node, and then the JS file. Okay, so we're going to give an example. Fabio, I'm not hugely over time, am I? So all good? So give a basic example of a Hello World Node one. We'll build it, we'll put it on the Docker Hub, and hopefully it all goes according to plan. I will take that chair actually. Okay, so here is a Docker file that is based off Alpine, which is basically like just a really small Linux one that's make it faster to download than if we used Ubuntu or something. We install Node.js, we add the one JS file that is our Hello World app. We don't need to do that. Remove that. Don't want to teach you the wrong things.
You are able to add entire directories.
You are, yeah. As long as you don't go dot to anywhere, you can add anything you like. Yeah. And then we're going to suppose port 9000, and when we run it, we're going to run that thing. So let's look at the app. It's copied and pasted straight from the Node website, right next to Aaron Hammond's photo. So, and so when we make a request to port 9000 in this app, it'll print Hello World, which will be great. So let's. Okay, so if you follow in the slides at home, then so we've got these two files.